Everyone, today we are going to discuss a very important question, that is, prove that the bisectors of the interior angles of a rectangle form a square. This is the question. Bisectors of the interior angles of a rectangle. You can see in this diagram ABCD is a rectangle. ABCD is a rectangle and angle A, angle B, angle C, angle D are of 90 degree. As you know that triangles of a rectangle are of 90 degree. Here what is given to us that AR, this DP, BR and CP, they are angle bisectors. So that is why I have mentioned it here alpha, 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 alpha every side, right? So what we need to prove that this PQRS that you see here becomes a square. This we need to prove that PQRS is a square. So as each angle of rectangle you know is of 90 degree, ABCD are of 90 degree and these are the bisectors AS, BQ, CQ, DS are the bisectors. So they bisect the right angle and this alpha becomes 45 degree. Each alpha becomes 45 degree, right? Now in triangle AST, this triangle we take, triangle AST. You know that the sum of the angles of a triangle is of 180 degrees. So this angle alpha, this angle S, this angle alpha, their sum is 180. Alpha is of value 45, so we substitute this value here. This angle ASD is as it is and the sum remains 180, right? So from this we calculate that angle ASD, that is this angle, is of 90 degree. If this angle is 90 degree, then the angle opposite to it, that is this one, PSR, this angle PSR, right, it is vertically opposite to this angle AST, which we proved 90 degree. So this angle also become 90 degrees angle. In the similar way we can prove, as you can see in all the triangles, this ARB, in DPC, in BQC, in all these triangles we can prove that this angle is 90 degree, this angle P is 90 degree and this angle R is 90 degree. When you prove this Q 90, the opposite angle also is of 90 degree. So clearly in this quadrilateral PQRS, all the angles are of 90 degree. So if all the angles are of 90 degree, then it becomes a rectangle. PQRS becomes a rectangle. Now we need to prove only this, that their sides are also equal. Opposite sides are equal, but we need to prove that this PS is equals to PQ and this SR is equals to RQ. But to prove this, what we are going to do this, firstly I'll prove that triangle AST is congruent to triangle BQC. See here you can see AD is equals to BC. This is alpha, this is alpha, this is alpha, this is alpha. So by angle side angle rule, the two triangles becomes congruent, right? So ASD is congruent to BQC. The triangles are congruent. So triangles are congruent, so then AS is equal to BQ and this DS is equals to QC, right? Now see here, so we have proved that this AS is equals to BQ and this DS is equals to QC. Now also in triangle DPC, you can see that this was alpha, this was alpha, this was alpha, right? So obviously DP is equal to PC. By using the criteria that if two angles are equal in a triangle, then their opposite sides are also equal. So DP comes equals to PC. And also we have proved that SD is equal to QC. ST is equals to QC by proving the two triangles group that I have proved it earlier, right? I show you here. We have proved that the two triangles are congruent, right? So that is how these two SD comes equals to QC, right? So by subtracting these two, PD, BC, SD, QC. This is PD, SD, right? PC, QC. By subtracting these two, we got PS equals to PQ. PS is equals to PQ. So if PS is equals to PQ, in the similar way we can prove that SR is equal to QR and all the four sides becomes equal. Hence PQRS is a square. So I hope you like the solution. It is very useful as the solution of a question that prove that the angle bisectors of a parallelogram forms a rectangle is very easily available, but this was a bit difficult, so I thought of finding out that solution and sending it to you. Thanks. Have a nice day. God bless you all.